Good morning and welcome all. Today in the engineering drawing subject, we are going to study the chapter Orthographic Projection. Now first of all, we have to know what is the need of orthographic projection. In an engineering industries, the communication of different types of drawings, whether it is solid or whether it is other types of objects or images, are carried out during the communications of one industry to another industry. So for the proper communication of the drawings, the orthographic projection and other types of engineering studies are required. So today in this lecture we will going to study the orthographic projections. Now first of all, what is the meaning of projections, or why the projection is needed? The projection is the process of creating an image of the object on the paper as it appears when observed on a particular direction. Means, for example, when we are doing any orthographic projections at that time and there is any real or 3D object, now the drawing of the image of the 3D object is not possible, or the communication of the 3D object in different industries, or to study this object in different industries or in other engineering design field is not possible, because the study of the different dimensions of this object are required. So for that purpose, the 3D object is converted into the different views of the images. So how we can able to carry out the different views of this type of project into different images? It is possible by the use of different projections. So as we see in this slide, the projection is a process of creating an image of the object on the paper which appears in the particular direction. Means when we see in any direction of this object, for example in the front direction, now in the front direction we will see this object. So the different dimensions we can able to carry out on a paper by using the projection. So it is the ray of lines which is passing through the object in any opposite direction or in any plane. So we can able to find out the different dimensions of the object as per the desired view. Now next one, we will see the image formed in the projection plane is in the projection of the plane. Means now when there is the image is formed or the rays of projections carried out from the object, now the images will appear in the plane. Now the images will appear in the plane which is go through or the tangent from the real object. So in the opposite direction of the plane we will find out the real images in the particular directions of the plane. Now the lines of the object in the plane of projection are called the projectors. The line which is passing through the object, so which forms an image, these are known as the projectors. Now we will see in the next slide the method of projections. Now in the first slide we have studied the projection. What is the meaning of projection? Now there are different methods of projection. The first one is the orthographic projection. Then we will study in detail in this lecture. The other types of projections are isometric projection, oblique projection and perspective projection. So we will see the introductory part of all this method of projection. The first one is the orthographic projection. The orthographic projection is a type of projection in which the projection rays or the lines of projections are parallel to each other, and also it is perpendicular to the plane of projection. Means the images which is carried out in the plane, the projections are perpendicular to each other and parallel to each other. Now next one is the isometric projection. What is the meaning of isometric projection? Now the isometric projection is the opposite or the inverse of orthographic projection. In case of isometric projection, the 3D object or the real object, as we see that the real objects are in 3-dimensional. So if you want to draw the imaginary object or the 2-dimensional object into 3-dimensional object, the isometric projection is required. So the isometric projection is required to draw the 2-dimensional object by considering the different views into the 3-dimensional or real object. Now what is the meaning of oblique projection. Now the oblique projection is as same as the orthographic projection, but difference is that the oblique projections are not in orthogonal to each other or right angle to each other. It is in the some angle, some desired or required angle from the projection plane. As in case there was the orthographic lines were right angle to each other in the case of the orthographic projection, but in case of the oblique projection, the lines of projectors or the lines of rays are at some angle to the projector plane. Now the next one is the perspective projection. Now the perspective projection is a conjunct rays, means it starting from the different rays, but it ends to the some one or a single point, which is said to be as the station point. So what is the requirement of using this perspective plane? The main application of using this perspective projection is in civil or architectural engineering, where the projections or the real-time objects of the different buildings or different dams, buildings and architectural drawings are required. In this case only the perspective projection is used. Now we will see the deep study of the orthographic projections. Now we see the figure of the object. In this case, the first plane, the vertical plane, as we can see, this plane is said to be as the vertical plane. This whole plane, rectangular plane, this whole plane is said to be as the vertical plane, and the right angle to this vertical plane is known as the horizontal plane. And in between the horizontal and vertical plane, the object is kept, this L-shaped 3D object. As we can see that it is a three-dimensional object. The three-dimensional object is kept between the horizontal and vertical plane, and this horizontal and vertical plane differs to this horizontal, this oblique line, right? Now we have to draw the orthographic projection of this image or this 3D object. Now this arrow shows the viewer direction. For example, we will see in this direction, so we can able to see this L-shaped object only, which is in the gray shade. This gray shade differs that this shows that we as we see from this direction, we can able to see this type of image only. Now when we do the orthographic projection, at that time the rays of the projection or the lines of projection will go in the tangent line to this object. So as the image is formed, in the opposite direction of the planes where the rays are in right angle to each other to the vertical plane. So as we see from this direction, or as we can say in the front view, the rays of projection will obstacles or will attach to the vertical plane. So in the vertical plane this type of image is created. Now it is the object which is given without dimension, but if the object is with dimensions, so we can able to draw this object by using the different dimensions. So the advantage of this type of orthographic projection is that we can able to see the viewing directions, we can able to know the object in different images. Means as if we are watching in the front view, then the image of the front view is projected on the particular plane, in the opposite plane, as we can see in this case the vertical plane, and also the different dimensions of the particular object can be easily obtained from this orthographic projections. Now we will see the real time object, and we will see the different types. Means the orthographic projections are divided into different parts or the different areas. So here is in the figure, as we had seen before, it is the vertical plane. This plane is the vertical plane, this plane is the horizontal plane, which is right angle to each other, and it differs by the line. This line is known as the XY line. This line is said to be as XY line, and the same, the object 3D object is kept over here, and the viewing direction is this. Now the projected plane, means the images which is projected on the plane is known as projected image, as we can see from this figure. Now the plane in which the projected image is transferred or is imagined is known as the plane of projection. So here the viewing direction is in this direction, right? So the plane of projection in which the image is projected is in the vertical plane. Now this object is said to be as the object to be projected. Now if any 3D object in which the object we have to projected, or any direction of the orthographic projection we have to create, so this object is said to be as object to be projected. Next one is the when we see in the viewing direction the lines of projections are created. So these are the lines of projection or the rays of projection. So it is object, right? Then object to be projected means it is the 3D object or real time object. Next one, it is the plane of projections, right? For example, we are seeing in this viewing direction, then the rays of projection will create in the parallel and perpendicular to the projection plane the image formed on the particular plane. That image is said to be as the projected image, and the lines or the rays is said to be as the lines of projection. That we have to remember. And this direction, when it is given that the arrow is given in the figure, this arrow is said to be as the viewing direction where the observer is watching or observing the image in the particular direction. This arrow is indicated as a viewing direction. Now we will further continue and see the different planes of projections. Now in the orthographic projections, when we want to project the image of any viewing any orthographic object, at that time we have to study 3 planes of projections, right? There are 3 planes, means there are vertical planes which is indicated by capital VP, horizontal plane which is indicated by HP, and auxiliary vertical plane. The line formed by the intersection of these 2 planes is known as the reference line, which is denoted by XY line. So this figure is the most important figure to understand the basic or the concept of the orthographic projection. Here this total rectangular image, as we can see this in the figure, this total rectangular figure which is in the vertical direction is said to be as the vertical plane or VP, and in the right angle or the 90 degree to the vertical plane, this is said to be as the horizontal plane, right? Remember well, it is the vertical plane which is in the vertical direction, and the at right angle to the vertical plane is said to be as the horizontal plane which is in the horizontal direction. Now this horizontal plane and vertical plane is differs by a line is known as XY line, as we had seen before, right? As it is written, the line formed by the intersection of these 2 planes. Which 2 planes? The horizontal plane and vertical plane is known as reference line. So this XY line which is seen in the figure is said to be as reference line or XY line, which differs the horizontal plane and vertical plane. Now this arrangement of horizontal plane and vertical plane creates the 4 quadrants, which is most important, right? As we can see in the figure, the 4 quadrants are divided as first quadrant, second quadrant, third quadrant, and fourth quadrant, which is in the same particular direction, which is in the anti-clockwise direction, right? The first, second, third, and fourth. Now the different views or the planes of projection will be different as per the considerations of the different quadrants. For example, when any object is kept in this quadrant, then the plane of projection is different, means the image to be projected on the particular plane is different, in the second quadrant also different, third, and same fourth. So the all the quadrants are most important, which we will see in detail in the further slides. Okay, now the possible positions of the object relative to the planes of the projection. This figure is the basic for the orthographic projection. If we will study this figure in detail or basically, then the orthographic projection will become very much easy. Now here in the further slide we had seen the vertical plane and horizontal plane. It is the isometric or the angular view of these planes. Now as we can see in the figure, this plane, this plane is said to be as a vertical plane, as we had studied before, and the right angle to this is said to be as a horizontal plane, which differs by the 4 quadrants. It is the first quadrant. See this quadrant, this angle made, no, this quadrant is said to be as the first quadrant. Behind this one, right, this one is said to be a second quadrant. Below the second quadrant, this is said to be as the third quadrant, and over here the last one, this quadrant is said to be as the fourth quadrant. Now when the object is kept in the first quadrant, right, so the object which is kept on the first quadrant in the horizontal plane, right, then the object which is kept is said to be as the above horizontal plane. It is written above HP and in front of VP. So the object is above HP, means it is the horizontal plane. If the project is kept over here, then it is said to be as above the horizontal plane, and in front it is the vertical plane, and the object is kept in front of the vertical plane. So this quadrant, when the object is kept, is said to be as above vertical plane, above vertical plane and in front of horizontal plane. So this quadrant, when the object is kept, is above horizontal plane and in front of vertical plane. That we have to remember, right? Now in the second quadrant, when the object is kept over here at anywhere in the second quadrant, then the position of the object is said to be as above horizontal plane. So it is the totally horizontal plane, and the object is kept above this is said to be as above horizontal plane, and the object is behind the vertical plane. It is a vertical plane, and object is kept in the second quadrant, that is, it is behind the vertical plane. So the object which is kept in the second quadrant is said to be as above the horizontal plane and behind the vertical plane. Now we will see